Wood has been a cornerstone of human construction and design for thousands of years. From ancient temples to modern homes, it's valued for its availability, workability, lightweight, and natural beauty. But despite these advantages, traditional wood has its limits. It's relatively soft, prone to warping, can break under pressure, degrade over time, and lacks the sheer strength needed for demanding applications. Now imagine a form of wood that is tougher, stronger, and more durable. So much so that it rivals the strength-to-weight ratio of steel. This is Superwood, an engineered material created through a simple but powerful transformation of regular wood. Developed by researchers at the University of Maryland, this wood could change the way we build everything from homes to vehicles. This wood offers a more sustainable and lightweight alternative to metals and plastics. Superwood isn't a new species of tree or a special kind of lumber. It's a high-performance material made by treating and compressing ordinary solid wood. The process alters the internal structure of the wood to make it up to 12 times stronger and 10 times tougher than its untreated counterpart. Despite being a far denser material, it remains much lighter than metals. For instance, it's about 6 times lighter than steel, while delivering comparable strength. At the heart of this transformation is the cellulose fiber, the primary structural component of wood. Cellulose is extremely strong, but in natural wood, it's surrounded by lignin and hemicellulose, which don't offer the same strength. This process strips away some of these weaker materials and compresses the cellulose fibers to make the wood denser, more aligned, and far more durable. The creation of superwood involves 2 main steps. First, the wood is boiled in a chemical solution of sodium hydroxide and sodium sulfite. This process partially removes lignin, which binds wood fibers together, and hemicellulose, which contributes to flexibility but not strength. After chemical treatment, the wood is heated and then compressed. This collapses the internal pores and aligns the cellulose fibers tightly. The result is a dense, compact structure that dramatically boosts mechanical performance. This process is not exclusive to any one type of wood, but it can be applied to a wide range of softwoods and hardwoods. However, the specific outcomes, such as strength, color, and texture, may vary based on the species used. One of the striking results of the densification process is the reduction in thickness. On average, superwood ends up being around 20% of its original thickness. In other words, this means a 1-inch thick board can become just 0.2 inches thick after treatment. This drastic size reduction plays a major role in the increased strength and density of the final product. The process works with most types of solid wood, but not with plywood or engineered panels. All natural wood contains cellulose, which is the key structural element that the process enhances. Differences in grain structure, density, and lignin content between species may affect the final results. Plywood and laminated panels are not compatible with the superwood treatment because plywood is made from thin veneers bonded with adhesives. The chemical soaking and heat compression used in the superwood process would damage the glue lines and compromise the integrity of the material. In short, if it's a single piece of wood, the superwood treatment process may work. If it's made from glued layers or composites, it won't work. Can this wood be worked on like regular wood? The short answer is yes, but since it's a much denser wood, extra care and better tools are needed. Standard woodworking cutting tools can be used, but sharp, high-speed tools are recommended. Tungsten carbide tipped blades or scoring blades provide cleaner cuts and reduce edge damage. Because of its density, hand nailing can be very difficult. Using a nail gun with resin-coated nails is a better and more effective way. When you're nailing near the edges, it should be done cautiously to avoid splitting. This wood can hold screws exceptionally well, and for the best results, drilling a pilot hole first is suggested and use only straight-shanked screws. Using a longer screw would be better than a short, thicker one for grip, and it minimizes splitting. This wood does not naturally resist water, and therefore, it needs sealing or surface treatment to prevent moisture damage. Regular wood's water resistance depends on the species, but it is also often treated for added protection. The core research behind Superwood was published back in 2018. Since then, interest has grown rapidly among material scientists and manufacturers. In 2025, companies like InventWood, a spin-off from the original research team, are beginning to commercially produce superwood for industrial use. Initial applications are expected in fields like construction, automotive manufacturing, furniture design, and military equipment, where high strength and low weight are crucial. Because this wood requires chemical treatment and compression, it will probably be more expensive than untreated wood. However, the cost is expected to decline over time as production scales and processes become more efficient. Early on, it will likely be used in high-performance or specialty applications where traditional wood falls short and the extra cost is justified. Superwood is an advanced, densified wood that offers exceptional strength and toughness by modifying the internal structure of regular wood. The treatment reduces thickness by up to 80% and is only suitable for solid hardwoods and softwoods, not plywood. As commercial production begins in 2025, this type of wood could become a go-to material in industries that require strong yet lightweight materials. From eco-friendly buildings to next-generation vehicles, Superwood is poised to change the way we think about what wood can do. Before you go, check out some of my other videos. Don't forget to hit that like button and subscribe. Thanks for watching. We'll see you at the next one.